Hello guys, hope all are fine. In today's class, we'll discuss most important algorithm that is one of the powerful assembly technique or one of the powerful assembly learning method that is the random forest classifier. Okay, so random forest, instead of building a single decision tree, okay, instead of using a single decision tree method, here we will use to make prediction and build many slightly different tree and combine their prediction. Okay, we'll discuss this technique in bagging. Okay, okay. First, we convert build many slightly tree differently and combine their prediction with voting. Okay, so these are the we have a single data set. So how do we obtain slightly differently? So first method is the bagging method using bootstrap aggregation. So what is bootstrap aggregation? We'll discuss in last class. So some overview, that is take random subset of data point from the training set to create a smaller data set. Okay, and fit a decision tree on each subset. And then second method is random subset method, that is also known as feature bagging. Okay, that is fit in different decision tree by constraining each one to operate on a random subset of features. Okay, so how it is work, we'll notice here. So it is a bagging technique. Suppose a random forest algorithm, it is a bagging technique, one of the most powerful bagging technique. Okay, suppose it is your data set. In your data set, suppose there is so many features. Okay, we'll draw. Suppose it is your data set. Okay, so here we'll use this data for training. Okay, and for this like this. Okay, so it is used for training, train. Okay, it is used for test, and this data. Okay, generally we will use for validation data. Okay, it is your validation data. And there is so many features like F1, F2, F3, like this, Fn in a data set. Okay, it is your suppose 1000 record total. Okay, it is 1000 record. Okay, suppose now we'll apply base learner, that is decision tree 1 on decision tree 2, decision tree 3, like nth decision. Okay, like this. Okay, after that, suppose this decision tree predict the value is 0. Okay, 0, and it is also 0, and it is also 1, it is also suppose 0. Okay, like this. So now we will do the aggregation. Okay, now we'll do aggregation, and notice the output will be 0. Okay, it is the majority voting classifier. Okay, majority voting classifier, and this is the aggregation. Aggregation, or you can say it is voting, which are majority voting, that is our output. Okay, and it is suppose your base learner. Okay, here we'll use the decision tree. In decision tree, there is a problem. Okay, in decision tree, suppose in decision tree, there is a problem that is overfitting. Okay, for reduce this overfitting, that is overfitting means training accuracy is high and testing accuracy is calm. For this overfitting, we will use the random forest algorithm to convert each dataset into some decision tree, and we will calculate or predict the each decision tree output, and then we will apply the voting process or aggregating, which is the majority, that is our output. Okay, so here it is your validation data. Okay, it is your validation data. In validation data, that is not used in training and testing. Okay, this is also d dash less than d. Okay, here d dash is row sampling. Okay, and if OOP score, that is out of bag score, equal to 2, then that is further splitting. Further splitting. Okay, out of bag score is your out of bag score is your validation data. Validation data. And this is also using cross validation. Okay, we'll discuss in cross validation. That is validation data using cross validation. We'll discuss some cross validation, that is k-fold cross validation, leave one out cross validation, time series cross validation. Okay, so that is your out of batch score, meaning that is validation data. Okay, so next, if you notice bagging at training time, if you notice this example, there are some apple is there and there are some orange is there. Okay, if you derive to or to some discernty, okay, suppose if you convert this to this discernty, then this is a discernty 1, okay, this is your discernty 2, this is your discernty 3, this is your discernty 4, like this. Okay, here you apply the discernty learning algorithm and you classify like this. Okay, here you notice the classify like this. Okay, and like this. Okay, after that, if you classify like this and a test sample is present in here. Okay, so here the test sample present in here, here, and here, and here. You notice if test sample is present in here and it is a apple. Okay, if test sample present in here, it is a apple. And test sample is present in here, it is a orange. And it is also a apple. So then you proceed for the voting or for aggregation. Okay, in aggregation, if you notice the majority, that is majority here is 75%. So 75% confidence is apple. So your output is apple. Okay, now I think you clearly understand the what is the bagging process. Okay, After that, okay, this is also your training data. Okay, in training data, suppose mass is 84 and one feature is color and one feature is texture and one feature is pH and one is the output feature that is dependent feature that is label. And these four are independent vector. Suppose you notice in 84 that is green and texture is smooth and that is 3.5. So you divide it like this distance to 1, distance to 2, distance to 3 like this. Then we apply the classify. Okay. So after classify you like some point is present here. Suppose you take this data set. Okay, if you take this data set, then this data set present here, here, and here. If you notice, here is apple, here the output is orange. For this distance 2, it is your distance 2, it is your distance 1, it is your distance 3. Okay, like this. Suppose you notice here, the apple is 2 and orange is 1. Okay, here that is 66% confidence for apple. That is for voting in aggregation. You will find the apple is the output. Okay, after that, it is your random forest. So like this, mass, color, texture, pH level, and you apply the banking plus random surface method. That is the distant learning. After that, you will convert the T1, T2 like T(n). You convert the n decision tree. Okay, after that you apply the voting process. After you apply the voting process, which have the major voting, that is your output. Understand clearly? So it is your random forest classifier. So generally, random forest classifier, it is your direct first you apply the learning algorithm that is recently. After that you classify this like this, then you apply the voting process, then you predict the output. Okay, it is your totally boosting process clearly in this image. Okay, so first is assembly learning method which we discussed in last class combines multiple learning algorithms to obtain performance and improve over its components. Commonly used assembly method we discussed what is bagging, what is random surface method, and what is boosting. Okay, you know bagging multiple model and random subset of data sample. A random surface method is multiple model on a random subset of features, and boosting is train model iteratively while making the current model focus on the mistake of the previous one by increasing the weight or misclassified sample, and it still grows like this. Okay, we'll discuss in last class. Okay, and then random forest are assembly learning method that employ decision tree learning to build multiple trees through bagging and random surface method. They rectify the overfitting problem of decision tree. Okay, they rectify the overfitting problem of decision tree. So random forest is a versatile and powerful classifier used in various domains for accurate prediction and features insights. Its ability to handle large dataset, maintain robustness, and provide feature importance makes it a popular choice in machine learning application. It is also a popular choice. Okay, for machine learning algorithm. Okay, so thank you.